OSG solutions for electric vehicles. This video's topic is the wheel assembly. The wheel assembly in a vehicle is comprised of multiple different parts. The focus of this product solution will be the wheel barrel and the wheel rim. The tire and wheel barrel are typically made with a die-cast injection mold. After the casting is completed, the wheel goes through secondary finishing processes such as turning and machining to get to net shape. After the automated machining processes, additional manual labor might be included. This includes polishing, which may need to be done in order to meet surface finish requirements. The rim and wheel barrel are typically made with a die-cast injection mold. After the casting is completed, the wheel goes through secondary finishing processes such as turning and machining to get it to net shape. After the automated machining processes, additional manual labor might be included, such as polishing in order to meet the surface finish requirements. The mold for the die casting is made from three parts: the top mold, the side mold, and the bottom mold. The top mold forms the cavity within the wheel. The side molds provide support to the casted wheel, and the bottom mold shapes and forms the spokes and other front-facing features of the wheel. These mold components are typically made from H13, hardened to the 40 to 45 Rockwell range. The machining process of these molds can utilize a wide range of tools as well as manual processing after the machining operations have been completed. Additionally, as the mold wears down from extended usage, there may be opportunities in the maintenance, repair, and overhaul of the molds. OSG's solution to the machining of either the mold or the aluminum casted part lies in the Phoenix Indexable finishing end mills. These end mills come in three basic configurations: a standard, strong or reinforced edge, and a diamond-coated configuration. For the machining of the molds, it is advisable to either use the straight edge or spiral edge type. While finishing the aluminum die-casted wheel, it is preferable to use the diamond-coated inserts. Oftentimes, these aluminum wheels will be machined using special PCD indexable tooling. The straight edge cutting type will be better in places where you may encounter a lot of interrupted cutting, whereas the spiral edge type allows a more free cut suitable for light processing. In this field test, the PFB was run in a 52 Rockwell steel similar to D2. In the head-to-head tests against various competitors, the PFB using the XP6703 insert shown improvements over tool life compared to the other three competitors, while still running at a respectable 62.7 inches a minute. In the same family of tools, OSG also offers a finishing indexable mill with corner radiuses. These tools come in a multifunctional, straight edge, and diamond-coated type. The usage recommendations are similar for the ball-nose version of this tool. Use the multifunctional or straightened edge type for the machining of the mold, and use the diamond-coated insert for the finishing of the tires. In this second application, the OSG PFR with the XP3225 insert demonstrated exceptional wear resistance after the machining of PX5D compared to the wear shown on the competitor tool. For the machining of the bolt holes in the hub of the wheel, OSG's TRA-HO offers an incredible amount of productivity. The three-flute design of the drill allows it to feed at least 1.5 times faster than conventional two-flute drills. Additionally, the DLC coating on the drill ensures an incredibly long-lasting tool when machining aluminum. Compared to a competitor tool, the TRAHO was able to feed at almost 3 times the feed rate, as well as improving the cycle time close to 3 times. On top of those improvements, the TRAHO was also able to machine 300,000 more holes than the competitor tool. Thank you for watching. For more information, please visit www.osgtool.com.